Hi everyone. Hopefully everyone can hear me okay. I think nearly everyone's joined, so we'll get started. Firstly, welcome and thank you for attending this webinar. This is our third in a series of webinars on test automation. We have 30 minutes today. The lion's share of this time will be spent running through a demo video showing a number of open source automation tools in action running against a native iOS and Android application on real devices. Before we start the video though, I'll run through the architecture of the automation framework we used and the tools we're running and how it all hangs together. A little bit about me. I'm Ash Gawthorpe, one of the co-founders of Ten10. My background is in hardware and software engineering, development and architecture with experience in technical testing and performance testing. In the interest of time, we will be rattling through this at some pace. If you don't quite understand part of this webinar will be available for streaming, so you will have the opportunity to stream it and review it again at a later date. As always with these webinars, if you have a question, please enter it in the chat window and we'll try to answer the question in this session, or if we don't have time, we'll reply to you individually. If you recall, in the last webinar, we discussed how organizations often have a need to automate more than one application. I also discussed how we would run through a demo automating an application using open source tools. Today, I thought it'd be really useful to kill a few birds with the same stone. We come across a number of scenarios where clients have essentially the same application running on different platforms. Normally, this means two applications performing the same task running as a native iOS application on an iPhone and as a native Android app running on an Android phone. There are ways to develop apps using a common code base that can be deployed as a native app across multiple platforms, but this approach is generally far from universally adopted. If we think about the manual test execution of a set of scripts against both apps, as the functionality is the same across both, the same test scripts are 99% the same across both the apps. So surely there must be some small differences between them. And there are, but they are reasonably small. So a common example is how values are entered on the different platforms. So for example, dates are entered differently. So on iOS, you have the date wheel that all iOS users will be familiar with. Android, it's different, but the end result is still the same. You're still entering a date. Behind the scenes, however, the apps are completely different. I mentioned just now it is possible to have the same code for both apps created using a tool like Xamarin, for example, but it's more than likely that these apps are written in different languages by different dev teams, or perhaps even by different independent software vendors. So they look and behave the same in the eyes of a user, but in the eyes of an automation tool, this is purely coincidental and they're as different as chalk and cheese. So given that everything is different about them on a technical level, but the apps only look and behave the same at a user interaction level, what's the best approach for automation? Well, rather than undertaking two separate sets of scripts, perhaps in different automation tools that both need to change independently, is there a way that we can reuse the scripts across both apps? In short, the answer is yes, in some scenarios. And in this demo, we're going to show you an example of how to do this. Okay then, so time to put this into practice. So for the purpose of today, we're going to be using a number of open source tools, and these are detailed on the next slide. If we start from the top then, we have Jenkins, an open source continuous integration tool. Jenkins glues everything together. Test execution, configuration, and reporting is controlled from within here. Depending on how much infrastructure you have and how quickly you want your tests to run, Jenkins will also manage multiple build slaves, orchestrating and managing the work between them. Also, build slaves can be running on different operating systems, particularly useful given the reliance of Apple hardware for iOS automation, and we'll come on to this in a minute. In this example, we're using one automation tool, but Jenkins also allows you to execute end-to-end tests using different automation tools, passing state between the different stages of tests as required. This approach gives you a standard, common, shared view, allowing everyone to build confidence and familiarity with one tool and one set of reports and one way to orchestrate and execute those tests, irrespective of the underlying driver technologies used to execute the tests on different apps running on varying technology stacks. So we're using an open source framework in this example called Appium. So this gives you a lot of good features that you'd want in an automation framework out of the box. So robust reporting through the Allure framework, capturing snapshots on test failure, and a whole lot of other boilerplate functionality that you shouldn't need to reinvent each time you implement an automation solution. This can be plugged in as required. Next, we come down to the script layer. At this layer, we have our tests. Note that while these tests are written in code, Java in this example running in Ten10, they should be readable by any layperson. It should be obvious what the tests are doing. If it isn't, then add comments so that it is obvious. One point to note here that the tests should be abstracted away from the underlying implementation. They should be separate. Tests are concerned with the setting up of state, interacting with the application, and then asserting whether what is returned is correct or not, i.e., for example, a logging test, taking a valid username and password, and then asserting that the response says welcome back or something similar. Crucially, there shouldn't be any code in here relating to interacting with the innards of the application or any of the controls. This makes it far more maintainable. Next, we come down to page objects. So this is a commonly used design pattern that encapsulates all of the nastiness related to interacting with a particular page or logical section or screen of an application. It's the page object that performs everything relating to interacting with the app here and here alone. That way, if the underlying implementation changes, you only have to change the single page object referencing it. You don't need to change the public methods used to interact with it, so there's no need to change the code in the test scripts. This is the point around maintainability. So next we come down to Appium. Appium is an open source automated test tool designed to interact with native mobile apps. And today we're looking at iOS and Android. So the scripts communicate with Appium using the same JSON wire format as Selenium. This means you can use the same API as WebDriver. Largely, if you're familiar with writing WebDriver scripts for browser apps, you can have a good go at writing scripts for native mobile apps. Because it uses that WebDriver wire format, you can also write the scripts you want in pretty much any language where there are WebDriver client libraries, which really means pretty much any language largely in use. If we move further down, we're getting closer to the hardware. So under the bonnet, Appium uses XCUI test for iOS automation and UI automation for Android. These tools aren't part of Appium. They're developed by Apple and Google respectively, and these are the libraries you'd use to automate either of these apps if you are writing specific tests to target each of these. Finally, at the bottom, we have the devices themselves. Now, I've skipped over a lot of the detail here, but this should at least point you in the right direction, both of the components used and how they all hang together. You'll also be able to Google any of the tools or technologies in this diagram and discover a huge amount of info out there on the web to satisfy your curiosity at any level of detail that you want, really. And just one final last point here. Essentially, we're writing code to test code. The same good code development practices that are used to develop code for the app should be applied to the code for test scripts. You can write these tests in pretty much any language you want. Our advice is to use the same language as a prevalent in-house dev team, if you have one, and I'd also advise you to adopt their coding standards, their source code management tools, and their review processes. Okay, I'm now going to run you through the demo. As we're running through it, please try to keep in mind the diagram on this slide, as each step in the demo relates directly back to a box on this diagram. Let's dive into the code then. So here on the screen you can see that we have the tests written in Java. If you recall me saying that here we shouldn't be seeing any selectors or any code related to the underlying implementation, we extract all that away. Here we're concerned with setting up the test, passing in the parameters for the test. So in this case here, username and password for a login test, for example, and then assuming that it's a valid combination, we want to assert that they log in successfully. So as you can see, these tests are fairly readable. So we've created two tests in this example. So one for registering an account and one for logging in and checking a policy. Note that you can see we have a nice textual description here, setting the description element on the test annotation so it's more useful than just the method name. You can see that we're setting up data. So in real life, not in a demo, you'd have the method itself taking in the date of birth and setting the email address as arguments so you're able to reuse it. So for example, if you have someone creating a policy who's too young, you'd expect it to fail. Or you'd also expect it to fail if they're already registered with that email address, for example. So note that all this code is executing on the terms and conditions page object, and we'll drill into that in a second. In the login and check policy test, you can see that we're using an object of type account, but actually selecting the first account in our data bank of test accounts we have. Again, in real life, you'd want to manage how you work across that spread of test accounts that you have. You can next see that we're clicking on login, setting the email address, date of birth, and password to the ones that are in the account that we extracted from our account management data bank. And we also skip the step here to create a pin. So now we've talked about the underlying page objects, but now we're going to drill into those. If you recall from the diagram previously, these sit below the actual test code and were referenced in the code that we just saw. So if we look at the login page object, we can see that for the web element register button, we have two Selenium identifiers with one locator for Android and one for iOS. So in this POC, it just sort of round robins between the two. Obviously better to have this as a configurable run option, depending on whether you're running iOS or Android. So how this works is we do this using the find all and find by annotations, with find all one wrapping both find bys. So find all ensuring it matches at least one criteria, and the find by matching all the criteria within that. So we know we're not going to match both because we're not going to be able to match both selectors on one single device. So in this case, it will set the web element to either the Android or iOS version, depending on which one it's executed in. So this allows you to have a single page object wrapping all the business functionality of the page and exposing the same web methods on both iOS and Android rather than duplicating effort. So as you can see here, we're doing this for each element that the page interacts with. Now, whether it needs to find it so you can check the value in it, whether it needs to find it so you can set a value in it, or just interact with it if it's a button, for example. So if we look at the select date of birth method, this is where the code base diverges based on the differences between iOS and Android. So the method takes a day, month, and year. That's called from within the test. All we want to know within the test is that we need to set it up with this date of birth. We don't care about the underlying implementation at the test level, but we do care about the implementation in this page object method here. So the first thing we need to do is to examine the platform property to see if we're running on Android or iOS. And if we're running on iOS, then we retrieve the picker wheel and interact with that. You can see that when we find the day picker, month picker, and year picker elements here using the selectors we defined earlier, and in this case you can see first of all we're doing this with the Android version. What we do is we then set the individual pickers to the values that were passed into the method. So in this way on Android we're setting up the day, the month, and the year. Once again, you can see that all this is encapsulated within the page object that deals with the nastiness and nuances of working with the individual devices. At a test level, the code remains elegant. All you're doing is you're just simply passing in the required date into a method and deferring the implementation to the underlying page object. So we also have in our project resources. Now these contain the specific devices. So defining the devices that we want to run the tests on. So if we take this iPhone 7, for example, we run an Appium server for each device. You can run multiple devices on a single server, but with iOS, you can only run one device, and with Android, you can have as many as you want connected, subject to sort of performance restrictions of the hardware. So each device has an Appium URL defined. So from a code perspective, we're just connecting to that URL, allowing us to run the code from anywhere. So we can put the code up in Git, for example. So this is how we parameterize the setting of the device type. So in this case here, you can see that the device is iPhone 7, the platform is iOS, custom browser implementation is set to Appium, and the app path is the path to the application. And again, this is local to the device itself. So we can run these tests from within the IDE, but far better to hook the tests up, as we mentioned earlier, to a CI tool. So in this case, Jenkins, as I mentioned, an open source CI tool. So under the hood, it's using Maven, it's using other reports, it's using a whole host of other plugins in the interest of us not reinventing the wheel again. So this gives us out-of-box reporting, allows us to run things in parallel if we have enough supporting infrastructure without us having to write all that code in order to support all those facilities. And if you recall in the last webinar, I mentioned one thing to plan is the amount of infrastructure required to run this. So not just the devices, but also the server-side infrastructure you're going to need for Jenkins build slaves. Let's execute some tests. We're using a product called Reflector to stream the output from the screen of the device to the desktop for this demo, so you're able to see what's happening on the device itself. In reality, you wouldn't be sending the output of the screens in this way. You'd be running the tests, and then upon an assertion failing, the framework would automatically capture a screenshot. In conjunction with the trace files, then you'll be able to see what the test had done already up until that point and what condition it was exerting on when it failed. So with this information alongside the screen capture snapshot, this will help you debug why the test didn't pass. The key take home here is that whilst they are very different, both applications at a functional level are doing the same tasks, in this case registration and logon, but again they do things differently. For example, here on the left you can see the scroll wheel on the iOS device for setting the date and the date. However, we're using the same high-level test scripts as you saw before to execute both of them. Just a quick note here around hardware. Android is pretty flexible in terms of the hardware you're able to run tests on. Windows, Linux, OS. The tool stack installs on pretty much anything. This makes building and configuring build slaves and running tests on Android emulators very easy. iOS is a different story. As mentioned earlier, Appium uses XCUI test for automation under the bonnet, and this requires Xcode and various libraries that can only be run on Apple hardware running OS X. There are numerous organizations trying to work around this and numerous projects, but there's not just the technical considerations, there's also the licensing restrictions. So whilst it's technically possible to run an OS X VM on non-Apple hardware, and if you Google it, you'll see that lots of people have done it, but it is illegal. You must have badged Apple hardware running OS X. Therefore, you'll need a Mac Mini or something similar. We've executed our tests. Now let's dive into the reporting a little bit. I mentioned Allure before, used for creating reports. You're able to plug this into Frameworkium, and so out of the box, you have some pretty good looking reports. This live reporting is invaluable for building confidence in the test pack and allowing different users to see the stability and readiness of the build. I'd also advise you to show this on screens and monitors around the office. If we drill into the tests on the S8, then you can see that we ran 2 tests with 100% success rate, and we can also see the historical trends. Again, not much to see here currently, but over time, very useful in understanding areas of the build where problems occur, tests that fail regularly, for example. And finally, we can see the timeline showing when tests ran on the S8. As I had mentioned a little bit on Reflector, just to be clear, the 2 devices that you could see on the screen earlier aren't emulators or simulators. They're a streamed output from the 2 devices' screens. As you can see here, if we click on the camera app and wave the phone around, I've mentioned before, don't do this in reality. The processing required to do this is quite heavy and will hit the performance of your test infrastructure. On that note then, everything I've mentioned so far has been running on physical devices. But what are the alternative options around this? Purchasing, maintaining and updating physical versions of the spread of devices used by your users isn't practical, especially when you consider you'll need to run on different versions of the operating system on each one. This is expensive but also tricky to manage. So you can run emulators for Android on any hardware, or simulators for iOS. Whilst this helps, for iOS you're limited again in that the simulator can only run on badged Apple hardware, so you need Mac Minis, Mac servers or something along those lines. There is, however, another option. There are numerous cloud-based service providers who provide access to physical and virtual phones and tablets in the cloud. There are a few commercial models, but as a rule of thumb, you pay for the amount that you use and you book time on them. So you can control them manually, but for the purpose of this demo, you are also able to run automated scripts on them. The example we're going to look at today is from BrowserStack. So BrowserStack allows you to run Selenium and Appium scripts on a variety of mobile devices and also different browsers, running on PCs as well as mobile devices, allowing you to reuse your scripts again and removing the constraint of you having to run on physical devices. So you can create a BrowserStack account for free to trial it. And what we're going to do now is we're going to show you the execution of the same scripts on BrowserStack, but this time against a Google Pixel, which is running in BrowserStack's test cloud. Okay, so in order just to round everything up and pull everything back together, I'd like to just run through a few summary points that we've raised so far on this. These are the ones that I feel are kind of important and worth really reiterating and kind of hammering home, essentially. So the first point is the idea that code is code, whether it's code that you're writing to test a product or whether it's code that you're writing which is the product. What you want to have is that unified development process, tools, the same development language if possible, as the ones which are used by your internal development teams if you have them. If you don't have internal development teams, it's all vendor-led, then maybe you could take the steer from them, or alternatively, if you have a completely greenfield site, then in this example, it's a case of looking at what skill sets you have within the team and within the organization. As I mentioned, because Appium is built on that WebDriver wire format, you're able to use pretty much any language which has bindings to the WebDriver client libraries, which is really pretty much any language in mainstream use today. This next point is around how you implement this. Again, you probably don't want to go big bang with this. You want to start small. You want to POC it, put together a proof of concept, make sure that all the tool stack hangs together, make sure that it works, get some buy-in from people before you invest a lot of money in it. But whilst you can start small, what's really important is that you start out right, and you start correctly, and you start off with the best processes that you're able to pull together and the best examples of code written in the best way. Otherwise, what tends to happen is whatever you start with, that tends to carry on. People will look at the code that's already there when they come to develop new tests, and they will base a lot of those new tests on that code. So if it starts out badly, it will continue badly, and as always, over time, if you're not careful, things will degrade a little bit more. So you need to keep an eye on that, and you need those robust processes in place to ensure that quality remains as the tests are maintained over time. From there, you can then start to build it out. And one more crucial point, make sure you revisit those tests and that you refactor them where necessary, and don't be afraid to remove those tests if they're no longer valid, or if they're no longer adding value, or if there are other tests that replace them. Remember, whilst there is a metric around how many tests you have, more tests doesn't necessarily mean that you have better coverage or that you have a better regression pack. But what it sure as hell does mean is that you will have a greater maintenance overhead. The next point here, just what I mentioned at the start around Jenkins, and the fact that Jenkins provides a great mechanism to pull together an awful lot of different automation tools, in this example using something like Frameworkium. So they're all under that umbrella. So irrespective of the different automation tools you're plugging into that framework, your testers, your users, your developers, your stakeholders, your business analysts, they all see one unified way of executing those tests, one unified way of generating reports, and one way of configuring any live dashboards that they want to see. And finally, one point that I have skipped over a little bit here, which really almost deserves a webinar in its own right, is around the complexity around iOS device setup and management. If all you're doing is deploying to Android devices, then great. If you are deploying to iOS devices, then just be aware that you may have a bit of a rocky road ahead in terms of being able to actually test the devices, in terms of having the devices or the code signed in the right way so that you're able to run automated tests on the devices that you have in the lab, around how you're able to extend that to something like Browser Stack, and around how you're able to use that for any simulators that you have. Okay, well I hope that's been useful, or at least a starting point and a few sort of pointers to get you started yourself. As ever, thank you very much for attending today. Just looking at the list here, we can't see any questions at the moment. But if we do have any questions coming subsequently, we'll make sure we answer each one for you. In terms of upcoming webinars, the next one we're going to be doing will be around test reporting, test analytics, and actually getting the value from that, because ultimately the value you get from that automation pack are the insights that you're able to glean and the actions you're able to take off the back of that. So the next one will focus on that. We're just finalizing a date at the moment, but we'll notify you via email, or also if you keep an eye on our LinkedIn group as well, when that next webinar will be run. Okay, so it just remains for me to say thanks very much for attending today. I hope that's been useful, and I look forward to you joining us in the next one, and have a good day. Thanks. Bye.